Okay, hello everybody. Welcome back. So, hopefully you watched my Algebra 1 series. That one was really short. This time, I'm gonna, so now we're gonna be going into Algebra 2. Now, Algebra 2 is a lot harder. I'm just gonna say it. I'm not gonna say it's easy or anything. It's not the easiest, but it's not the hardest. It's just a little complicated sometimes. So in the last one, when you saw the syllabus, it was really simple, right? A few things. This time, oh god, there's a lot of things in this. Most of it is in parentheses because they're just like what topics are in, what topics, and all that. But beyond that, there's just a lot of topics. And in this, you have the basic understanding, right? So this will be a lot. So there are more topics because there's more like different topics, I should say, because now you know the basics and you can apply them more and go deep. This is kind of like algebraic analysis. Yeah. So first I'm going to talk through the curriculum because there's a lot, and then so first in this video we're going to talk about.
I'm gonna sleep.
Now?
Yes.
Why?
Because I have nothing to do.
Why didn't you do? Did you finish the math counts?
Well, I did the ones that I could.
Just finish the math counts.
No, I'm tired. No,
Good.
but I know. Yeah, I'm just gonna lay in bed.
Okay, stay on the call though.
I'll mute myself.
So first we're gonna talk about rationalizing, denominators, and polynomials, like what they are, and we're also gonna be talking about quadratic inequalities. Next we're gonna talk about circles and ellipses. Then we're gonna talk about complex numbers, which is like a new topic. Then we're gonna talk about functions, and studying them and notation. Then we're going to talk about dividing polynomials. After that, we're going to talk about set theory. This isn't like a whole topic. It's just like a mini topic, just some notation, you know. Then we're going to talk about solving polynomials, part 1. After that, we're going to talk about solving polynomials, part 2. Then we're going to talk about sums. After that, we're going to talk about inequalities. Inequalities, kind of like a competition thing. They're not in the usual Algebra 2 curriculum, but they're really cool and they're helpful in competitions a lot, especially in high school ones. Then we're going to talk about radicals. Then we're going to talk about rational equations. After that, we're going to talk about exponential equations and log equations and interest, like compound interest, simple interest, continuous compound. After that, we're going to talk about piecewise functions, like absolute value, floor, ceiling, and others. And we're also going to be graphing them. Then we're going to talk about more advanced sums in series, or more advanced sequences in series, like recursive ones, telescoping, polynomials, arithmetical geometric series, and then we're going to talk about finite differences in the end of this. And the ones that have starred are the ones that are optional and that are not in the usual curriculum. They're just there because you can use them, and I don't think they're going to be in the tips and tricks of algebra, so I'm keeping them in this one. And I like them, so yeah. Honestly, there's a lot. Some of these even I'm not fully clear on, but yeah. Because I shared this with a lot of people, I want to just be safe. Right, better to be safe than sorry. And I'm gonna box it this time. So do not erase. Hopefully they understand that. Otherwise, they're probably gonna, so I'm gonna just take a picture. Screenshot. There you go. Nice. So now we're gonna jump right into it. So rationalizing denominators, polynomials, and quadratic inequalities. So first thing is rationalizing denominators. So let's say we had something like 4 over the square root of 3. Now, is it just me, or I don't like square roots or cube roots in the bottom. I like it when they're on the top at least. Or if they're gone, that's okay too. So to get rid of this, we multiply by the square root of 3 on both sides, on both top and bottom, and we get 4 times the square root of 3 over 3. Now if we had 6 over the square root of 3, we did that times the square root of 3 over the square root of 3, because the square root of 3 over the square root of 3 is just 1. So now we get 6 square root of 3 over 3. But because 6 over 3 is 2, we get 2 square root of 3. Now, that was kind of simple. What if we had cube root of 3? So 6 over the cube root of 3. We can't multiply by the cube root of 3, otherwise we're going to have 3 times the cube root of 9. So we need to multiply by the cube root of 3 squared, or the cube root of 9. And that gets us to 6 times the cube root of 9 over 3, which is equal to 2 times, and this, hopefully you learn in pre-algebra, that is 3 to the 2/3. Yeah, now we know how to deal with those. If we had 4th root, we multiply by to the 3 over 3 over 4, right? To the power 3 over 4, right? Next up, we're gonna learn about more rationalized denominators, but a harder case. What if we had 4 over the square root of 3 minus the square root of 2? We can't multiply by one number, so we can use for difference in squares. If you multiplied by the square root of 3 plus the square root of 2 on both top and bottom, we're gonna get 4 root 3 plus 4 root 2 over root 3 squared minus root 2 squared, or 1, which is equal to 4 root 3 plus 4, 2. And actually, fun fact, that's actually approximately 4 pi, I think. Next up, yeah, and then if you had cube root, then you could use difference of cubes, I think. Stuff like that. Yeah. So we get that now, hopefully. Next up is, what's next? Polynomials. And then quadratic inequalities. I'm gonna first do quadratic inequalities. So remember our old buddy, ax squared plus bx plus c. Oh god, that was a long time ago. So, we're gonna erase that. Ugly. So now, ugly duggly over there is gonna be used too. So instead of ax squared plus bx plus c is greater than 0, or is equal to 0, or what am I doing? Equal to 0? What if we had inequality, like less than 0? Or what if we even had greater than 0? Or what if we had greater than or equal to? Or what if we had less than or equal to? Right? Lots of things. So I'm going to use a method that I was taught in my school. So first you said equal, right? We need to know where the roots are. So now what we're going to do is we're going to make a grid. So we're going to make a chart like that, okay? Where this is a number line, okay? This is the number line. So you have 0, 1, 2, 3. So negative 3, negative 2, negative 1, 0, 1, 2, 3, right? So on both sides. So now, let's say we had something like, I'm gonna do many problems. So I'm gonna use our old buddy, x squared plus 5x plus 6 equals 0. Then I'm going to do x squared plus 5x plus 6 is greater than 0. Then x squared plus 5x plus 6 is less than 0. Then x squared plus 5x plus 6 is greater than or equal to 0. Then x squared plus 5x plus 6 is less than or equal to 0. Okay, let's do that. So now, if x squared plus 5x plus 6 is equal to 0, we factor, we get x plus 2 times x plus 3 equals 0. By the way, moving on in Algebra 2 and pre-calc and calc, we're not gonna do all the Algebra 1, because Algebra 1 we know, and we expect you viewers to know it and understand fast. Like, we don't want you to like do it piece by piece and all that. So we're just gonna simplify the algebra for you. Unless we have to go through it step by step, but that's rarely the case. So, like in this case, I didn't go through factoring, I just factored. So that means that x is equal to negative 2 and negative 3. Now you might think here that x is greater than negative 2 and negative 3. That's not the case. That's not the case. So what we do now is we have our two lines. So we plot the 2 points. So the lines are at where the solutions are, negative 3 and negative 2. That's where the vertical lines are. Now, here we have, now on the right, we write out the two factors. So we have x plus 2 and x plus 3. Now what we do is we say that x plus 3, if it's below negative 3, it's negative. If it's above negative 3, it's positive. And if it's above negative 3 but below negative 2, positive. And if it's above negative 2, it's also positive, right? So because at negative 3 is 0, so above that is positive, below is negative. Now x plus 2 is going to be negative until the 0, and then it's going to be positive. So it's negative. So x plus 2, if x is below negative 3, it's negative. If it's between negative 3 and negative 2, it's negative. If it's above negative 2, it's positive. And then at the lines is 0. So now what we do is we multiply. So a negative times a negative isn't positive. Negative times a positive is a negative. It's positive times a positive is a positive. So if x squared plus 5x plus 6 is greater than 0, that means that it's greater than, so that means that it's positive. So that happens when x is less than negative 3 and x is greater than negative 2, right? It's positive here on and here down. So now, if it's less than 0, where is that? That means it's negative. So it's between negative 3 and negative 2. Notice there's no greater equal to. So there's no equal to here. So that means that x is between negative 3 and negative 2. So it's greater than negative, so that means that it's greater than negative 3, but less than negative 2. Between those two, right? Again, none of those. Now here, we're gonna have those equalities. So if it's greater than or equal to 0, it's just the greater than 0, but also equal. So we have x is less than or equal to negative 3, and x is greater than or equal to negative 2. Okay? And then this one also goes here, so we have negative 3 is less than or equal to x, which is less than or equal to negative 2. And that's basically how you do it. So that's how I was taught. You do like this graph thing. Yeah, and when you get to cubics and stuff, higher polynomials, you do the same thing. You just graph them all, gonna have these many lines. Maybe this will be like that and like that. There's more, so it's gonna be like that. Right, stuff like that will happen, but yeah. So yeah, now we're gonna talk about polynomials and what they are and stuff like that. So polynomial is really just any expression, but that has only one, or yeah, it has unknowns, right? Usually just one, x, or sometimes it's a and b, many things, but yeah, and they're usually in the form a1 x to the they're usually in the form an x to the nth plus an minus 1 x to the n minus 1 plus an minus 2 x to the n minus 2 plus a1x plus a0 or a0. Now this might look really complicated, but all it's really saying is that you have some coefficient of x to the highest power, which is usually called the degree. So the degree deg of p of x is equal to n. So an minus 1, an minus 2, all the way to a naught are just numbers. They're coefficients, like a, b, and c in the quadratic formula. But what if, but we use a, b, and c because, yeah, but now what if there were 27? What if n was 27? Then there's not enough letters. So, and we're going to use e, z, and stuff like that, and we don't want to do that. So we just use these subs. So yeah, so now but the polynomial cannot have square roots or fractional powers. It cannot even have negative powers. Nothing like that. Positive whole powers. Yeah. And we're actually going to be learning how to solve any polynomial later, and that gets really complicated. But if you stay with me, it'll be okay. Now I'm going to talk about adding and subtracting polynomials. So, and multiplying. So let's say you had 3x to the 4th plus 4x cubed plus 2x squared minus 1 plus 5x cubed minus 2x plus 4x squared minus 3. The first step when you have something like this is to first put this in ascending or in descending order. So first we flip these two. So we get 4x squared minus 2x. Okay. Then what we do is we if it's plus, we just remove the parentheses, right? Right now we look at all these with 3x to the 4th, with all the numbers that have x to the 4th, and there's none, except for this 3x to the 4th. So we have 3x to the 4th. Then how many? Now what has x cubed? So this is 5x cubed. So we add 9x cubed. Then we look at squares. We get 2x squared, and there's 4x squared. So there's 6x squares. Then we look at the x's, and there's none in this first one, but in the next one there's negative 2x. And then we look at the the constants, which is -1, -3, so -4. That's our answer. Simple like that. Now we're going to talk about what if we subtracted. So what if we had, what if we did minus instead? So now remember, we're going to put a parentheses first because now they matter more. When you have minus, we're not just minus, we don't know what to do. So first we write out the first one, so 3x to the fourth in descending order, 4x cubed plus 2x squared minus 1. Then we distribute the negative to everything. So you have minus 5x cubed minus 4x squared plus 2x plus 3. So we're really just flipping the sign of everything on this. So this positive becomes negative, this plus becomes negative minus, this minus becomes plus, this minus becomes plus, right? Now what we do is, now we can simplify, and we get 3x to the fourth, 4x cubed minus 5x cubed, so minus x cubed, 2x squared minus 4x squared, we get minus 2x squared. No x term, but there is a plus 2x, minus 1, plus 3, there. And that's our answer. So, it's really simple. It's not that hard to add and subtract. You just simplify the minus, put it in descending order, and then you look for like terms. If it erases, I can move on to multiplying. It's really laggy, I think. Okay, yeah, there. So now I'm going to talk about multiplying polynomials. This one's a little harder. Remember, expanding and factoring. So when we expand, right, those were just numbers and constants and stuff like that. But this time we're going to do polynomials. Again, I'm going to use this thing, remember, right? So let's say this is 4x squared, 3x, and 2. And then this is going to be this side is going to be, let's say, 9x, no, 9 is too big, 2x cubed plus 4x squared plus 3x plus 7. Now what we do is, if we're now we're trying to look for what is, so we're looking for what is 4x squared plus 3x plus 2 times 2x cubed plus 4x squared plus 3x plus 7. Now, again, remember, we just multiply every pair, right? So we do this first times the first times second, first times third, first times fourth, second times first, second times third, second times third, second times fourth, third times first, third times second, third times third, third times fourth, right? And so we look here, so we do 7 times 4x squared, and that is 28x squared. And we do 7 times 3x. I'm using this grid, and we just divided it up. So 7 times 3x is 21x. 7 times 2 is 14. 3x times 4x squared is 12x cubed. 3x times 3x is 9x squared. 3x times 2 is 6x. 4x squared times 4x squared is 16x to the fourth. 4x squared times 3x is 12x cubed. 4x squared times 2 is 8x squared. 2x cubed times 4x squared is 8x to the fifth. 2x cubed times 3x is 6x to the fourth. 2x cubed times 2, 4x cubed. Now we have everything. So the area of this whole thing, or what we're looking for is just so first we're gonna look at the highest degree, so it's 8x to the fifth, and there's none of those, so there's only one, so 8x to the fifth plus all the 1 to the fourth, so we have 16. So this is 16x to the fourth plus 6x to the fourth, which is 22x to the fourth. Now notice actually that we have, so all the x to the fifths is this, x to the fourths are these, x cubes are these, x squareds are these, and then x are these, and then 14 is, and then constants are this. Cool, right? It's just, it creates a pattern. So plus 22x to the fourth. Then there are 3 x cubed terms from this diagonal pattern. I'm gonna erase it because I can't see. Okay, and now we have, I'm just gonna keep those. So now all the x cubed terms are 24, 28. X cubed. Then we did that. Now we have x squared terms, which is 36 plus 9, or 45. X squared plus 27x, right? 21 plus 6 plus 14. So we did it. Oh, there's no plus. Okay, we did it. Now we could have also expanded everything, right? Wait, is this right? Not right to 2? Wait, what? Huh? Sorry, no, this isn't right to 2. Okay, 28x to the 5th. There we go. Now we're done. Wait. Oh, wait, no, sorry, no, I was right the first time. Okay. This is a 2. Right there. Okay. There. So that's it. Done. That's multiplying. Dividing is a harder, and we're gonna talk about that later. A little bit before polynomials and solving them. Do some examples. Do some practice. Thanks for watching, and I'll see you guys next time when we talk about something. When we talk about circles and ellipses. Anyways, goodbye.